So this lesson is on the chain rule, which enables us to find derivatives of compositions of functions. So here's going to be our first example. I'm going to say that y equals x squared plus 3x plus 2 to the 7th power. And here's our basic idea, dy dx, that's the derivative with respect to x of y. Dy dx, that's what we're looking for, will be dy du times du dx. And you'll notice you can kind of think about the fact that the du's sort of divide out. Now, it's not completely correct, but it's a nice way to think about it. So the inner function is what I'm going to call u. So u is going to equal x squared plus 3x plus 2. If that's the case, then y equals u to the 7th. So down here, I'm just going to make a note. Y equals u to the 7th when I make that substitution. Well, I need du dx. How do I get du dx? That is the derivative with respect to x of u. Is the derivative with respect to x of x squared plus 3x plus 2. So the derivative with respect to x of u is, of course, du dx. And the derivative with respect to x of x squared plus 3x plus 2 would be 2x plus 3. So that's du dx. We see this. Now down here we said y was u to the 7th. So I need dy du. That would be the derivative with respect to u of y, which is the derivative with respect to u of u to the 7th. So we're going to say dy du is 7 u to the 6th. So that's dy du, and this is dy du, so I can go ahead and make my substitution. So what do we get? What's our answer going to be? Dy dx equals dy du, 7u to the 6th, times du dx times 2x plus 3. Again, noticing du dx is 2x plus 3, and notice dy du is 7u to the 6th. But there's one more thing that I need, because I'm not quite finished yet. I have to substitute in this u. And we can see up here that u is x squared plus 3x plus 2. So my answer is going to be dy dx will equal 7u to the 6th. So x squared plus 3x plus 2 to the 6th times 2x plus 3. You may be tempted to simplify this. I'm not. I mean, we're trying to discuss the properties of the chain rule. So I'm okay with leaving it in that form, at least in this example. So let's take a look at another one, similar kind of a problem. Let's take a look at y equals 1 over the square root of x squared plus 6. How am I going to do that? Well, I think I'd like to rewrite this. So I'll rewrite it as y equals 1 over x squared plus 6 to the 1/2 power. So again, rewriting it one more time, y equals x squared plus 6 to the negative 1/2 power. And this will enable me to go ahead and define my u and my y. So u is the inside function here. U is x squared plus 6. So the derivative with respect to x of u is the derivative with respect to x of x squared plus 6. So du dx is the derivative of x squared is 2x, derivative of 6 is 0, it's just 2x. So I have that fact. Now remember, what do we need? We need dy dx. We said dy dx was dy du times du dx. So we have du dx. We've done that analysis over here. We have du dx. Excuse me, we have du dx. I need dy du. I need dy du. Well, what is y? Y is u to the negative 1/2. So I need dy du, take the derivative with respect to u of both sides. So I get dy du equals negative 1/2 u to the, decrease the exponent by 1, negative 1/2 minus 1. Dy du is negative 1/2 u to the negative 3/2. Okay. We're going to want to go ahead and make that substitution. So what do I get? Dy dx, the derivative of my original function, dy dx equals dy du, negative 1/2 u to the negative 3/2. Times du dx, which was what? Which was 2x. Now this one we probably should simplify a little bit. Certainly negative 1/2 times x becomes negative 1, so we get negative x. So my next line is dy dx. Negative 1/2 times 2, negative 1 times x, negative x times u to the negative 3/2. But let's make that a little prettier. What will that give us? Dy dx equals negative x times 1 over u to the 3/2. But what was u? What was u? U is x squared plus 6. So I can say dy dx is negative x times 1 over u squared plus 6 to the 3/2. Excuse me. U is x squared plus 6. X squared plus 6 to the 3/2, substituting in u for our x squared plus 6. And then finally, my answer will become upstairs negative x, downstairs x squared plus 6 to the 3/2. Which you could rewrite many different ways. You could rationalize the denominator. I'm not terribly interested in doing that. Again, we're trying to sell the notion of the chain rule. So I am okay to live with that. Let's take a look at one more, looking at the chain rule from this perspective. If I have y equals sine of 7x. We're going to need to define u. So this time u is 7x. And du dx is 7. Dy dx is dy du times du dx. Y is sine u. So the derivative with respect to u of y, with respect to u of sine u, dy du is cos u. And let's finish this. So we'll say dy dx equals dy du, which is cos u, times du dx, which is 7. But what is u? U is 7x. Dy dx is cos 7x times 7, which we usually write our answer as 7 cos 7x. So that's our basic idea of the chain rule.